Welcome to Unveiling the Universe, the James Webb Space Telescope. Today we're diving into everything you need to know about JWST, from its groundbreaking origins to its mind-blowing discoveries that are rewriting our understanding of the cosmos. Launched as the successor to Hubble, this engineering marvel is peering farther back in time than ever before. Let's blast off. The story of JWST begins decades ago, even before Hubble launched in 1990. It's a collaborative powerhouse, a joint mission between NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA. Thousands of scientists, engineers and technicians from 14 countries and over 29 U.S. states contributed to its design, build, and testing. Assembly happened at NASA's Goddard Space Flight Center, with a total cost of about $10 billion. The telescope is named after James E. Webb, NASA's second administrator, who oversaw the Apollo program. JWST's design is nothing short of revolutionary. It's the largest telescope ever sent to space, with a primary mirror 6.5 meters, 21.3 feet across, over twice the size of Hubble's. Made of 18 hexagonal segments coated in gold for optimal infrared reflection, it folds up origami style to fit inside its Ariane 5 rocket. Once in space, it unfolds like a transformer. A massive 5-layer sunshield, the size of a tennis court, blocks heat from the sun, earth, and moon, keeping the telescope at a chilly -223 degrees Celsius, -370 degrees Fahrenheit, equivalent to SPF 1 million protection. Unlike Hubble, which orbits Earth, JWST sits at the second Lagrange point, L2, about 1.5 million kilometers, 930,000 miles, away, orbiting the Sun for a stable cold vantage point. JWST launched on Christmas Day, December 25, 2021, from French Guiana aboard an ESA-provided Ariane 5 rocket. After a month-long journey, it reached L2 on January 24, 2022. The deployment was nail-biting. Over 300 single-point failure mechanisms had to work perfectly. Miraculously they did, and by July 2022, JWST released its first full-color science images, exceeding all expectations. At its core are 4 cutting-edge instruments. NIRCam, near-infrared camera, captures sharp images and helps align the mirror. NIRSpec, near-infrared spectrograph, analyzes light from up to 100 objects at once. MIRI, mid-infrared instrument, sees through dust clouds to reveal hidden stars and planets. NIRISS, near-infrared imager and slitless spectrograph, specializes in exoplanet atmospheres and primeval galaxies. These tools allow JWST to observe in infrared, seeing heat signatures invisible to optical telescopes like Hubble. JWST's objectives span the entire history of the universe, peering back over 13.5 billion years to the first galaxies after the Big Bang, studying galaxy formation and evolution, observing star and planet birth in dusty nebulae, analyzing exoplanet atmospheres for signs of life, exploring our own solar system, from distant icy bodies to comets. It's designed to serve thousands of astronomers worldwide for at least a decade, building on Hubble's legacy. Now, the fun part, discoveries. Since 2022, JWST has shattered records. In its first year it spotted thousands of ancient galaxies, including the most distant one ever, challenging theories on early universe formation. By 2023, it found life-supporting molecules like water and methane on exoplanets, imaged solar system worlds in new detail, and confirmed the Hubble tension, a mismatch in universe expansion rates. In 2024, highlights included detecting failed stars, brown dwarfs, methane on exoplanets like WASP-80b, and the deepest infrared views of nebulae like Carina. 2025 brought even more: ancient surfaces on trans-Neptunian objects, a new Uranus moon, a possible direct collapse black hole, and interstellar comet 3I, Atlas. It revealed bizarre astronomy's platypus objects, point-like galaxies with unusual spectra, and an abundance of massive early galaxies. By early 2026, JWST captured the most distant supernova, a carbon-rich exoplanet orbiting a pulsar, and stunning views of galaxies like Jade's GSZ 13-1, and nebulae such as the Butterfly and Lobster. It even found a potential water-world exoplanet, and 300 mysterious luminous objects at the universe's edge. Plus, jaw-dropping images of spirals like NGC 2566 and Cassiopeia A in new dimensions. In December 2025, it earned a spot in Time's Best Inventions Hall of Fame. And in January 2026, lead optical engineer Lee Feinberg received the Spee Goddard Award. Compared to Hubble, JWST is a game-changer. Hubble excels in visible and ultraviolet light from low Earth orbit. But JWST's infrared vision penetrates dust and sees farther, up to the universe's first light. It's not a replacement but an extension, revealing what Hubble couldn't. Looking ahead, JWST has fuel for 20-plus years and continues as the premier observatory. Ongoing projects include exoplanet habitability studies like K2-18b, galaxy classifications via citizen science, and more surprises in our quest for cosmic origins. Who knows what it'll uncover next? The James Webb Space Telescope isn't just a machine, it's our window to the stars, inspiring generations. Thanks for joining us. Subscribe for more cosmic adventures.